Now we will do certain problems on determinant without expanding the determinant. We will use the properties of the determinant to solve these problems. 1, 2, 3, 4, 5, 5 and 6. Now we'll start with the sixth one. Before that, I will give you the idea of Van der Monde determinant. Let's see. Let's start from here. Let's start from here. Van der Monde determinant. Now, if we have 1 like this, 1 x1 square up to so and so forth, x1 n minus 1 1 x2 square up to so and so forth, x2 n minus 1 and so and so forth up to 1 x n minus 1 x n minus 1 square up to x n minus 1 n to the power of minus 1 1 last is 1 again x n square x n to the power of n minus 1, which is basically a n cross n determinant. So the easiest way to calculate it is start from this last row. From this last row, you write xn minus 1 into xn minus 2 in the subscript, so and so forth, multiply with xn minus x2 and xn minus x1. Now continue with the multiplication. Now start with xn minus 1 minus xn minus 2 up to so and so forth. You multiply of xn minus 1 minus x2 into xn minus 1 minus x1 and continue with this multiplication till you have x2 minus x1. Now we will use this concept to solve this problem. Now you see, because this is of the form of this problem is of the form of a Van der Monde determinant. Now you see how to do it. Just see how to do it. I'll copy that problem again. It was 1, 1, 1, a square, b square, c square, and this was a 3 cross 3 determinant. Now start writing with c minus b, c minus a, and b minus a. Now what you need is, you need it in that form. Take a minus common from this option and take a common from this one. So take a minus out of this and out of this. See, I'm taking a minus out of this, b minus c minus a, and take a minus again into, I'm taking a minus 1 into a minus b. This minus 1 and this minus will become plus. So rewriting it again, a minus b, b minus c minus a. I hope you've understood the way the Van der Monde determinant is used to solve this type of problem. Then this was method 1. Now we will use, before we'll row operations. Before that, I'll tell you some row operations. Wait. Now we will talk about row and column operations. Row and column operations. First, I'll tell you the row operations. Row operations, which are very, very important. Row operations and column operations. Column. Okay, wait a minute. It's overwriting. Column operations. Right? Now, what is this? This is Ri is replaced with Rj. The ith column is replaced with the ith row is replaced with the jth column, or jth row. Sorry, the row. This is the row interchange. This is the interchange actually. Interchange. Similarly, you will have this type of interchange as Ci to Cj. The column interchange is the row interchange. This is the column interchange. Now Ri is to be replaced with k times Ri, or similarly Ci is replaced with k times Ci. K is some number. This k is different, this k is different, or they may be same. Now Ri is to be replaced with Ri plus Krj. Similarly, Ci is to be replaced with Ci plus K Cj. Jth column, ith column. Here the ith row and the jth row. This is the difference. Now we will use this concept to solve this problem, this problem. We'll solve this problem now using this concept. I use the Vandermonde method to solve this. Now I'll use these row operations to solve this problem. Now you see how to solve it. Oh, wait a minute. I think, yes, let me take it a little up more. Yes. Now I will write down the problem again for you. 1, 1, 1, A, B, C, A square, B square, C square. What you do is that try to make this zeros. Try to make a zero here, try to make a zero here, try to make a zero here. That's the idea. Basically, as many zeros possible. You have to make it an upper triangular matrix. I think I told you in my first lecture, types of matrices. Now, let me rub them. Let me rub them. Now see the operations that I'll take. R2 row is to be replaced with R2 minus R1, and R3 row is to be replaced with R3 minus R1. So what happens? 1a square remains, 1 minus 1, that is 0, b minus a, that is b minus a, and here you get b square minus a square, and here you get 1 minus, again this one is 0, c minus a. Using this operation now you have c square minus a square. Now what you do is that you write 1a square, 0 b minus a. Now b square minus a square is b plus a and b minus a. You have this. And then 0 c minus a, c plus a and c minus a. I hope you are understanding. Take b minus a out of this, c minus a out of this. So what are you left with? B minus a, c minus a, then 1a square, 0, 0, 1, 1, b plus a and c plus a. These are what you are left with. Now use the plus, minus, plus sign. So now you only have to expand with the first row and the first column. The rest are 0, you need not. So what you do is that b minus a, c minus a, then you expand with this 1. So what you left with? 1 b plus a, 1 c plus a. Now what you have to do? You have to cross multiply this. So now what you get is b minus a. Let me take a little more page. Yes, b minus a, c minus a. No, let me write it here. Wait, let me write it here. Let me write it here. Wait. B minus a, c minus a, then now cross multiply, put a bracket, c plus a minus b plus a. This is b plus a. Now you have b minus a, c minus a, then you have c plus a minus b minus a. Opening the brackets, a and a cancels out. What you get is b minus a, c minus a, and c minus b. Now what you need is a minus b, you need a b minus c, and you need a c minus a. So take a minus out of this, take a minus out of this. So they become plus the way I did in the earlier method. So what I do is this, I take a minus out from here. This is a minus b. Now c minus a remains as it is. And from here I take another minus common, this minus and this minus. This is b minus c. Now this minus and this minus becomes plus, and what you get is a minus b, b minus c, and c minus a, which was your required answer. So these are the two methods of solving the same problem. Now let us see the first problem. We'll go this way. Now the fifth problem. We will take the fifth problem into account. In this, we will be seeing how this cube root of unity is needed. I told you in that lecture of cube root of unity. Wait, sorry, wait. In the cube root of unity, I already told you one very important structure, that 1 plus omega square is 0 in cube root of unity. I hope I told you this thing in that chapter. So I'll use this concept to solve that problem. What I have is 1 omega square and omega square 1 omega square 1 omega. What I'll do is that I will add up this row, and this row. What I'll do is that R1 is to be written with R1 plus R2 plus R3. So the first row is now replaced with 1 plus omega square, omega plus omega square plus 1, and omega square plus 1 plus omega square 1, omega square 1 omega, and this is going to, now this, to take this common out from all of the rows. Now what you do is that, let me take some page. Now you see, I take this thing common out. So what I get is 1 plus omega square is out. And then what I've got, 1 omega square 1 omega square 1 omega. And this quantity is 0, as I know. I told you. So 0 into this whole stuff, 1 omega square 1 omega square 1 omega. This is going to give me an answer 0. Now, why did I tell you the nth root of unity? Let us see one very important structure of this problem. How this problem has been structured out. Suppose I write in this manner 1 omega square. I can myself create this matrix. This determinant I can create myself. Now let me write with a different color. This one here. Now this and this start with 1 in an anti-clockwise direction. 1 omega square. Now start with omega square 1. Then with omega square 1 omega. So this is the way you can create the determinant itself by looking at this anti-clockwise sense of that concept that I told you. Now, of the cube root of unity. Now let us see how to use the nth fourth root of unity, create a 4 cross 4 determinant. Now supposing, wait, wait. Supposing I have fourth root of unity, that is x to the power of 4 is 1, but x is not equal to 1. What are the roots I'll get? 1 omega square and omega cube. Now see how to create the matrix, right? Determinant, I should rather say. 1, this is 1, this is omega square, this is omega cube. Now write in anti-clockwise sense. Start from here. 1 omega square omega cube. Now start from here. Omega square omega cube. This is, I think, cube, yes. And this is 1. Now start with this. Omega square omega cube 1 omega. Now the last line. Start with omega cube. Omega cube 1 omega square, and this will also give you 0 because of the earlier result. This is the implication of fourth root of unity. How can you create a determinant like this just by looking at this thing? Now let us see our first this. I think I'm going in the opposite direction. Yes, now we have the fourth question. If A, B, C are different and A, B, C, this is 0, prove that 1 plus ABC is equal to 0. Now you see this has to be proved. Now what I'll do is that I'll copy this determinant there and we'll solve it. Now the thing is, this is the way we will do it. Wait, let me draw a line. Yes, the line has been drawn. Now 1 plus, although the determinant was, what was the determinant? Let me recheck it. The determinant was, yes, A, B, C, A square, B square, C square, and then with 1 plus you are having. Okay, fine. Okay, now see. A, B, C, A square, B square, C square, 1 plus A cube, 1 plus B cube, and 1 plus C cube. This was given to be 0. I had to prove A, B, C is equal to 0. Now, how to prove this? Now I told you this, you can break this determinant into a, b, c, a square, b square, c square, 1, 1, 1 plus a square, a cube. Then you have b square, b cube, c square, c cube. This is equal to 0. Now what you do is that you take this whole, from here you take a common, from here you take b common, from here you take c common. What happens? Now you interchange this and this. So first you interchange this, then you interchange this with this. See, 1, 1, 1, a square, b square, c square, a b, sorry, a b c, plus you take a b c common here. You have 1, 1, 1. You have a b c. Then you have a square, b square, c square. This is equal to 0 they have given. Now let me take more page. Now interchange these two. There will be a minus sign because there was 2 row. Now again there will be a minus sign because these two will be changed. So minus 1 in minus 1. This will be 1, 1, 1. Is a b c, a square, b square, c square plus a b c, 1, 1, 1, a b c, a square, b square, c square. This is equal to 0. Take this determinant common, and this 1 plus 1 into minus 1 is plus 1. So here it is basically 1. So 1 plus ABC, this becomes 1 actually. This ABC and the determinant 1, 1, 1. ABC, A square, B square, C square. This is equal to 0. Just now I expanded it using Vandermont's method and or the other method. So you have the result here. 1 plus ABC. Then you have A minus B, B minus A, and C, B minus C, sorry. Wait a minute, let me rub it. B minus C and C minus A equal to 0. They have given in the question that A not equal to B not equal to C. So neither of this will be equal to 0. This will not be equal to 0. This will be not be equal to 0. And this will be not be equal to 0. So 1 plus A plus B plus C is 0, hence proved. This is the way it has been proved. Now let us see the other questions. Let us see the other questions which we have. After this, we have third question. Yes, the third question is this. Now, A, B, B, C, A, Q, C, A, B, R is 0. Then evaluate this. Where P minus A is not 0, Q minus B is not 0, and R minus C is not 0. We need to evaluate this determinant. Let me copy it down. Let's copy this down. And then we will carry on with our work. Now see here. Let's copy this. Let me draw the line. Wait a minute. Wait a minute. Yes, the line has been drawn. Now what they have given me is this. See, P, B, C, A, Q, C, and A, B, R. This they have given to be 0. And they have asked me what is the value of P. Let me write it. P small p upon P minus A. What they have asked plus Q. Q minus B, what they have asked, plus R, R minus C, when P minus A not equal to 0, Q minus B not equal to 0, and R minus C not equal to 0. This is the thing. So what I'll do is that I want P minus A. I want P minus A concept. I want a Q minus B, and I want a R minus C. So that means I have to subtract this rows from this C. What I will do is that I'll do one thing. I want to get, I will do R1 is R1 minus R3, and I will do R2 minus R3. I'll keep the third row as it is. Now see what happens. Let me take some more page. Now see what happens. Now see what happens. Now this becomes P minus A, B minus B is 0, and C minus R, you're getting C minus R. Now R2 minus R3, subtract this with this. A minus A is 0. Q minus B, you are getting C minus R, and you are getting A, B, R, and this whole quantity is 0. Now, the thing is this, the best way to expand this, either you use this expansion, this way, this row way, you expand it now. There's no other option. You have to expand in the row way. Now see how, let me take some more page. Let me just keep this matrix. Yes, now put a plus sign on the top, minus sign here on the top, plus sign on the top. Now just hide this row, and hide this row and column. Sorry, this row and this column. This row and this column. Now you see. Let us write it. This is equal to P minus A. Take this Q minus B, C minus R, B R. There is no need to use the zero sign because the zero is here. You need not to expand with that. Leave it. You take plus C minus R. Then what you do is that you hide this column. That's all. That is, wait a minute. Just a minute. You hide this. Now you have 0, Q minus B, A and B. Just cross multiply and expand. So in this, what you will get is, see, you will get P minus A, and after this multiplication, and you will get this, you will get as R, Q minus B, and minus B, C minus R. Wait, C minus R plus C minus R. You will get, this is 0, minus A, Q minus B. This will be equal to 0 because this is all equal to 0. Now, solving this, now you try to solve this. P minus A, then you solve it. R Q minus RB minus BC plus BR plus C minus R. Then you have minus AQ. So what you do is that take A here and interchange the sign. B minus Q equal to 0. This will do the job. Let me write it properly. Let me write this A properly. Wait. A. Now you have the cancellation this way. Now what you have is this. Now let me take some more page. Get me some more page. Sorry. Yes. Now what you have, this picture with you. So you have in this, you have now three quantities. P minus A and this R. See, here you have to multiply and okay. Now P minus A, or you could have done this also. Wait, this could have been easier. Instead of opening up this bracket, I could have done this thing. That would have been easier. Why? I'll tell you. Instead of cancelling this, I could have done one more thing. The thing is, it would have been easier. Wait, this cancelling uh, would create a trouble for me. Wait, I'll tell you a easier way to get over this, because I need, see in the question, I need P minus A in the, sorry, it's just a minute. P minus A in the denominator, Q minus B in the denominator, R minus C in the denominator. That's the idea. That's the idea basically. So what I'll do is that, let it be like this. Multiply this with this. R, P minus A, Q minus B. Let it be. Minus B, P minus A, C minus R. Plus, let it be, if you want to keep the minus, no problem. Keep the minus, wait a minute. Minus A, C minus R, Q minus B. Let's see what we need in the denominators. We need Q minus B, we need R minus C, and P minus A. See, P minus A is there, and R minus C, instead of R minus C, we have this, no problem right now. See, divide this whole equation by, divide this whole equation, this is equal to 0. Divide by what? P minus A, Q minus B, and C minus R. C minus R. Now dividing this equation, this complete equation by this P minus A, Q minus B, and C minus R, we have R over C minus R, because this component and this component goes off, and this component and this component goes off. Now in the next part we have minus B by Q minus B, because those two are parts cancel out. Now in the third part, this part, we have minus A, P minus A, right? Now this is equal to 0. Now what I do is that multiply with a minus sign throughout. So we get minus R, C minus R, plus B, Q minus B, plus A, P minus A. Now with this minus sign, I convert this C minus R to R minus C. So let me take some page. Yes, it is here. Now R upon R minus C plus B upon Q minus B plus A upon P minus A is equal to 0. But we have, if you see the main equation, we have a P here, we have a P here, we have a Q here, we have a R here, this R is here, this Q is here, and this P is here. But here in this equation, we have B and A. What I need to do is that I need to remove this B and remove this A. So what I do is that I add B upon Q minus B. I add plus 1 here, and similarly I do is I add a plus 1 here, and I add 1 and 1 on both sides, so that the equation remains same. Now taking the LCM on this part, I get R upon R minus C plus B plus Q minus B upon Q minus B plus A plus P minus A upon P minus A, and this is equal to 2. Now B and A cancels out. So what I am left with is the solution. That is R upon R minus C plus Q upon Q minus B plus uh, I think it is P. Yes, P upon P minus A is equal to 2. I hope you have understood this problem. And the next problem we will take is now, I think this is the, wait, I think, yes, we will have to take the second problem. In this problem we will have to now take, what we do is that, see, I'll copy that problem there. We will do this problem here. I'll draw a line. Wait. We will draw a line here. Wait. Sorry. Okay. Just a minute. Yes, here we are. Let us draw a line. Now we have A plus B plus 2C, and we have C and C. We have A and B plus C plus 2A. We have B here, we have a B here, we have a and we have a C plus A plus 2B. Now can you see, I have to prove this is equal to 2 times A plus B plus C cube. Now with this very idea of 2 outside, I need to get 2 in each A and B. What I do is that I add column wise. I write C1 equal to C1 replaced with C1 plus C2 plus C3. So what it becomes, let me take some more page and let me do this problem for you. Now see, if I add this column with this column and this column with this column and this column, wait a minute, read up this now so that you don't get confused with this. Now what we have is, we have A here and B here. So I get 2A plus 2B plus 2C. Similarly, in this and this, if I add, I get 2C plus 2B plus 2A. Now, similarly, if I do this here, I get 2C plus 2A plus 2B. The remaining part is all the same. A, then I think this is B, and this is C plus A plus 2B. Now I take this portion, from this portion I take 2A plus 2B plus 2C. From all these portions, from this column I take this common out. Let me rub this, otherwise. Let me rub this. Now what I do is that I take some more page. Yes, now, wait, yes, here it is. I take 2A plus 2B plus 2C common. So 1, 1, 1. A, B plus C plus 2A, B, B, C plus A plus 2B. Now what I do is that I try to make this 0. Wait. Now the next option is, next part is R2 is to be subtracted with R2 minus R1, and R3 is to be replaced with R3 minus R1. Now in the next part, we will see 2 can take common, A plus B plus C. This 2 has come out. You can see 1AB. Now 0, it will be A plus B plus C, because this minus this will give me A plus B plus C, and this will be a 0. Now similarly, this will be a 0, this will be a 0, and this will be C plus A plus B. Now I will take the determinant in this in the column respect. In the column respect, I'll take the determinant. Now let me rub this line. Now let me expand it. Now see 2A, 2, wait a minute. Yes, just a minute. Okay, 2A plus B plus C, and you are expanding the determinant. A plus B plus C, 0, zeros. This is A, C plus A plus B, one and the same thing. Just a minute. Let me write B properly. Yes. B. Now you are cross multiplying. So what you get is 2. A plus B plus C and A plus B plus C whole square. This will give you 2A plus B plus C whole cube. I hope now you understood this problem. Now the last problem for you is this one, which I have kept it, is this one. Now let me draw the line. Yes, the line is here for you. Now the question is 1 plus A, 1, 1, 1, 1, 1 plus B, 1, 1, 1, 1, 1 plus C, 1, 1, 1, 1, 1 plus D. And I need to show that this is equal to A, B, C, D, 1 plus 1 upon A, 1 plus 1 upon B, 1 plus 1 upon C, 1 plus 1 upon D. Now you can see in this, there is no 1 upon A anywhere. There is no 1 upon A. So what I do is that I can do it either the column way, or I can do it the row way. That's up to you how you want to do it. Whatever, suppose I have a 5. I multiply with 2 and divide by 2. It is again 5. This concept I'm going to use here. Now what I'll do is that I will multiply this this complete row. First I'll multiply outside with A, and then divide the complete first row by A. 1 upon A plus 1, 1 upon A, 1 upon A, 1 upon A. Similarly, I will multiply by B outside and divide the second row by B. So 1 upon B, 1 plus 1 upon 1 by B plus 1, 1 by B, 1 by B. Now, similarly, I will multiply outside by C. This concept I am using everywhere. 1 upon C, 1 upon C, 1 upon C plus 1, 1 upon C, 1 upon D, 1 upon D, I will multiply with D here, sorry, and then 1 upon D, and 1 upon D plus 1. Now the idea is to get this combination. To get this combination, I need to add all the rows. Let me take more space. Yes, here. Now you see A, B, C, D. Let me write the operation first. Let me write the operation for you. R1, just a minute. Yes, R1 is to be replaced with R1 plus R2 plus R3 plus R4. This is the operation. Achha, now you have A, B, C, D, and then if you add it 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D. Similarly, you will get a 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D. Similarly, you will get here 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D. And in the last section, you will get 1 upon A. This is A. This is A plus 1 upon B plus 1 upon C plus 1 upon D. So this is D. Wait a minute, let me write it clearly for you. This is now D, and let me draw the complete this. Now 1 upon B, 1 upon C, 1 upon D. Now here I have 1 upon B, 1 upon B plus 1 upon C, 1 upon D. This is going to be 1 upon B, 1 upon C plus 1 upon D, and 1 upon B, 1 upon C, 1 upon D plus 1. Now this is common in every in the first row. This whole thing is common in the first row. I'll take this thing out. Now let me take some more page. Yes, here this is A, B, C, D, and this can be written as 1 upon A, 1 upon B, 1 upon C, 1 upon D, and here I take this as 1, 1, 1, 1, 1 upon B, 1 upon C, 1 upon D, 1 by B plus 1 by B, 1 upon, sorry, 1 by C, this is C, this is C, this is C, 1 upon D, this is 1 upon B, 1 upon C plus 1 upon D, 1 upon, this is now 1 upon B, 1 upon C, 1 upon D plus 1, this is D. Let me write it clearly, this is D. This is D. Now, this is 1. And then now what I do is that since there is a 1, 1 and 1 here, I will use the column operation to make them 0. I will try to make them 0. I'll try to make this one 0, try to make this one 0 and this one 0. This all I want to make them 0. So I'll use only column operation. Now let's rub this for you. Wait. Let's rub this. Exactly. Exactly. Now, see, I'm using column operation. What I am using is, that the one has vanished, sorry. I have to write, let me take some more space. Yes, yes. Now see, what is the column operation? C2 is C2 minus C1, comma, C3 is C3 minus C1, and C4 is C4 minus C1. Now see, this is now A, B, C, D, then 1 plus 1 upon A, 1 upon B, 1 upon C, plus 1 upon D, and then now with the column operation, this becomes 1, 0, 0. I'm using the first operation. Wait. So 1 by B minus this, you have 1 by B, you will have 1 here, 0, 0 here. So you will have 1 upon C, this will be 0, 1, 0, and this will be 1 upon D, this will be 0, 0, 1. After this, uh, I will expand the determinant in this in the first row, plus minus plus minus plus. Okay, sorry, this is sorry. Wait a minute, plus, and this is minus on the top, on the top, on the top, on the top. Now these zeros do not make any contribution. So what I'll do, I'll expand with the first row only, and my job will be done. Now let me take some more. Yes, here, here, here. Now you see, you remove this so that you don't have any problem understanding this. Now you have this, I remove this. Now what I have done is, I've expanded it. A, B, C, D, 1 upon A. This is A. Wait a minute. This is A plus 1 upon B plus 1 upon C plus 1 upon D. And then with this one, I have this one. I'm talking about this one. I have 0. Uh, I have this thing will come here. Wait a minute. This thing will come here. I'm expanding with respect to first row and first column. So I will have this one. 1 0 0 0 1 0 0 0 1, and this is nothing but an identity matrix. This is all multiply. So the determinant of an identity matrix is 1. Therefore, the answer is A, B, C, D, 1 plus 1 upon A, 1 upon B, plus 1 upon C, plus 1 upon D. See, I have done one thing. So we have got the answer, and I have done one thing. You can see here, I have done one thing. I have, oh, I forgot this thing may have been removed by mistake. Now, see, here what I did, I divided the rows. I divided the row by A and I divided here by A. I could have done this other way around. I could have divided the column by A, column by B, this column by C, and this column by D. And then instead of this row, I could have taken the column operation. And then here, it would have been a row operation in this place. So with this, I have done all the problems.